Hello everyone, this is Srinivasan from RMDEC Engineering College. In this video, I'm going to talk about support vector machines. It's a supervised learning algorithms and it is used to solve both classification and regression tasks. It is used to find the best possible line or decision boundary that separates data points of different data classes in case of classification problems. The unique aspect of SVM is it differentiates the two classes by identifying the optimal hyperplane that maximizes the margin between the two closest data points of opposite classes. The number of features in the input data determine if the hyperplane is a line or 2D space, or a plane or in a n-dimensional space. The key aspect of SVM is it maintains the margins. So let us define the term margin. See, the lines that are adjacent to the optimal hyperplane is known as the support vectors. These vectors are run through the data points that determine the maximum margin. So the gap between the support vector is called margin. So SVM tries to maximize the margins so that it differentiates the data objects of two different classes significantly. We have used two types of SVMs, linear SVM and non-linear SVM. Depends on the data set. We are choosing any one of them. See, let us take linear SVM. It is used to solve linearly separable data. So for a linear SVM, the data will not be transformed to any specific form. So it can be applied directly on the input data sets. So it tries to identify the hyperplane, which is nothing but a line, okay, to differentiate the data points. It uses two approaches for calculating the margin or maximum distance between the classes. One is hard margin, another one is the soft margin. The hard margin is data is calculated by finding the distance that perfectly separated outside of the support vectors. On the other side, the soft margin is more flexible. It allows certain misclassifications. So because it's not a strict boundary, here the hyperplane adjusts the margin as a larger of points are placed very close to the support vector. So there is a chance for misclassifications in case of soft margin. So this diagram shows the difference between the hard margin and the soft margins. See, in the hard margins, no points, okay, will be placed in between the support vector. But in the soft margins, we can find some data samples. Okay, but the number of samples will be minimum in the soft margins. As a result of this placement, it will lead to some misclassification. Then we move to the non-linear SVM. So most of the real-time data are non-linearly separable. So we use non-linear SVM more often for solving those problems. Here we are using the kernel functions. The kernel functions are used to transform data higher dimensional space in order to separate the data more clearly. So you look at the real-time data. Here we are taking the non-linear data points. So it's very difficult to draw a decision boundary to differentiate these two classes. So the remedy is the kernel functions. So kernel functions is used to draw some polynomial curve or boundary so that the classes can be differentiated. It is possible by transforming these data points from one dimension to higher dimensional space. So look at these diagrams. Here we are finding some high dimensional space where the data points belongs to a particular class are accumulated on one side and they are clearly separable from the data points of another class. So the kernel functions are used to collect the data points belong to particular class at one point or one area. So we can easily separate the data points. We have used so many kernel functions from linear kernel functions to sigmoid functions. This slide shows some of the popular kernel functions we have used in the SVM. So you look at the advantages of SVM. We are using it to, for solving many problems. So we can use it to solve both linear as well as non-linear problems, including multi-class classification as well as regressions. It reduces the overfitting problems, so it is more stable compared to other machine learning models, and it can work easily with other models as well as it can operate on the high dimensional data easily. Its computational speed is also higher compared to other algorithms. So look at the major limitations of SVM. Um, it takes more time uh, to create a model, and it is highly sensitive to its parameters, and it is not interpretable like decision tree. So these are the some limitations of the SVM. Thanks for watching this video.